I would like to introduce our first keynote speaker for today. So, introducing Gene Kim. Gene was the CTO of Tripwire, and he's not just a CTO, he was the original author who actually coded the original version of Tripwire back in '92, and he's currently working on his third book. He apparently didn't learn his lesson in the first two books. Gene, you're writing a book. Gene is writing a book, When IT Fails, a DevOps novel. It is my great honor and pleasure to introduce to you Gene Kim.
Hi, thank you so much for the introduction, Jim. My name is Gene Kim. I'll be talking today about an area of passion I've had for about 13 years, which is starting to study a group of high-performing organizations that had the best security, the best compliance, the best operational performance, the best project due date performance. And back in 1999, when I first started studying these organizations, we called them geniuses of people with great kung fu. So I had the privilege of being able to study these organizations back when I was the CTO of Tripwire. And I'd like to share with you some of my key learnings and how this has converged on rugged DevOps. And maybe just to set the context, what I'd first like to do is just share with you what these high performers were all about. So for those of you who don't know, sort of geniuses of people with great kung fu. These are people who led these high-performing IT organizations. And one of the things that we noticed 13 years ago was that they talked differently, acted differently, but the most important part was they had profoundly different operational results and outcomes than your typical IT organization. They came from one of three professions. They were either a non-commissioned officer in the military, they were a chemical engineer, or they were an auditor, right? Not just any bean counting, green eye shade wearing auditor, they were an IT auditor. Right, so can anyone speculate or hypothesize what these three professions have in common in terms of their values of these professions? Non-commissioned officers in the military, chemical engineers, and auditors. Anybody? Discipline. Discipline, I love that. Right, that's a great word. Any other words come to mind? I'm sorry? I got discipline. Any other words? Process, good, good. Any others? Attention to detail. You got it all, right? So the words that we chose were rigor and discipline. Right? Why? Non-commissioned officers give ammunition to 18-year-olds, right? And I learned in restaurant operations that they don't even like giving knives to 18-year-olds, right? Because you combine knives and raw carrots, you get accident rates so high that insurance companies get involved. Chemical engineers have long, elaborate recipes where if you missequence 2 steps, endothermic can become exothermic. And then auditors, they just love controls. So that's what led to benchmarking over 1,500 organizations. I helped raise over $1 million for an organization called the IT Process Institute, really trying to link controls with performance. We benchmarked over 1,500 organizations, really trying to figure out what specific controls we could attribute to these phenomenally different outcomes. But what I've found in this journey is that there's actually something terrifying happening in information security. That where this journey has led me is straight into the heart of the DevOps movement, which I think exposes some of the largest problems that we have as a profession and some of the largest business challenges that we have in the world. So what I'd like to do is share with you a story in 4 acts. The first act really begins with operations, right? So if you're in IT operations, if you've done time as an ops guy, right, you maybe have been put in situations where you are maintaining a very significant business application, or you're working on a project that has a significant amount of business emphasis on. Right, and the problem is that these things tend to get fragile, right? And so the reason why we call it fragile is that these things are breaking all the time, right? Someone looks at it wrong, and it breaks and blows up, and it takes a long time to figure out what went wrong, right, in order to restore service. One of the sort of embarrassing parts about fragile applications is that we're always the last people to find out about it. In other words, the detective control, right, the monitoring mechanism that actually told us there was an outage isn't a monitoring control. Right, it's actually a salesperson calling me up and saying, "Hey, Gene, why are all the banner ads in my market being served upside down and in Spanish? Right, what happened?" And then when there's so many moving parts, when the application is sufficiently complex, it always takes a very long time to figure out which bit got flipped. Right, and that's what we need to undo in order to restore service. So when you have genuinely significant business applications that are fragile, something else happens. Is that the business starts missing the commitments it makes to the outside world, right? So sometimes it's letting customers down, sometimes it's commitments to make to analysts, sometimes it's commitments to make to Wall Street. And so when these things happen, something very, very bad happens. Even worse than fragile applications is that the business starts making even larger, more audacious commitments to Wall Street, right? Often dreamed up by these people, right? The product managers, right? Who are often creative writing majors, art majors, right, who don't necessarily have the best idea of what technology can and can't do, right? And by the way, let me just state for the record, some of my best friends are art majors, right? They're fine people, but these are often not the best people to be setting commitments to the outside world in terms of what the roadmap of the company is going to look like. So when that happens, we enter Act 3, which are the developers. So the developers, right, now they start seeing urgent, date-driven projects put into the queue, right, where a commitment has already been made to the outside world. And when that happens, right, we have to start taking even more shortcuts, right? And so that means, the operational requirements are never fully addressed, and certainly that means that the security requirements are going to be the last to be addressed. And so that means even more fragile applications, even more technical debt. And then, I love the word technical debt, right? Technical debt, to me, the image it conjures up is this, right? Technical debt is, all the things that weren't done quite right because all the corners we took either in the development, testing, or in the operations process, or certainly in the security and hardening process. And the reason why I call it debt is that debt compounds, right? So that this eventually becomes this, right? You think it can't get worse, and then it does. One of the things that I've seen over and over again is that it's not fragile applications become more fragile. Something else even more insidious starts happening is that applications start taking longer to deploy, right? So applications that used to take an hour to deploy takes 3 hours, takes a day, takes a weekend, which is okay, right? Because at least we can work throughout the weekend to get things deployed. Then it says taking 3 days, right? Which means that now we can no longer do it in a weekend. Takes a week, takes 2 weeks. There was a specific project I was working on where a deployment took 6 weeks and over 1,300 steps to actually deploy, right? And when that happens, releases start slowing down, right? And suddenly, feature deployment intervals start lengthening. So think you have a problem, right, when the deployments become so burdensome, so complex, is that the business says we need to lengthen the deployment intervals, right? In other words, we have to amortize the cost of deployments, to make it, because it's so painful, which may go against everything you believe in, right? Because everything that we've learned in manufacturing says we have to shrink batch sizes. You want to shorten the deployment intervals, right? And when you lengthen the deployment intervals, things go the wrong way. And so when this happens, right, when these deployments get more and more complex, right, you have even more moving pieces, more fragility, and then enter Act 4. Now you have full-blown warfare between the operations people and the developers, right? And so the expression on the developers' face is like, hey, we committed the code, good job, right? We're going home, and the operations people are saying, but you set the whole data center on fire for the entire weekend, right, and caused us, 40 person hours of unplanned work, right? So then enter Act 5, which is information security, right? Is that, IT is not an all-you-can-eat buffet, right? By the time this happens, there's nothing left for information security, right? All of the hardening guidelines we put in, all of the security remediation tasks, right? All of those are now on the backlog, and we have a feeling that we're never going to get these fixed, right? When these things happen, this is when everybody in the IT organization, whether you're in product management, development, ops, or information security, we all feel trapped in a system that preordains failure, right? That we are powerless to change the outcomes, right? And the business is actually going to lose as a result. By the way, how many people here can resonate with any elements of this story? Yeah? So that's interesting, right? So for me, this is the downward spiral in 5 acts that I think actually occurs in every IT organization just as a side effect of how we're organized. And let me just sort of paint this case. There's a school of thought in the theory of constraints that says that this is a core chronic conflict, that this will occur because we have sort of two simultaneously, two business needs that result in two diametrically opposed goals, right? In other words, you have your VP of development who's compensated or motivated to respond quickly to urgent business needs, right? Which means ship as many features as you can. Right? On the other hand, you have the VP of operations or the head of security saying we have to create a stable, secure, and reliable IT environment, which means make no changes ever, right? Make no changes over my dead body, right? Which I've learned can quickly be arranged, right? And so this is where you end up with these core chronic conflicts. And yet, we know that there's a better way, and I'll share with you why I think DevOps is that way. Just in terms of painting significance, I think this is an important problem because every company, every organization, regardless of what business they think they're in, is actually an IT company, right? And here's the numbers that really bear this out for me. One is that 95% of all capital projects involve IT in some way, and that 50% of capital spending is technology related, right? So this is every organization, large or small, regardless of what industry, profit, not-for-profit, right? You're going to see these characteristics so that IT is a core competency. And I think another indicative evidence point is that regardless of where an organization is versus where we want to go, IT is always in the way, right? We're sort of constipating, the digestive tract of the organization, right? So there must be a better way. And this is where my journey has taken me, which is straight in the heart of the DevOps movement. So let me give you a quick primer on what DevOps is. And in fact, I'm so delighted there's a rugged DevOps track. I'll be going to almost all those. I'm going to go to as many talks of those as I can. So the DevOps movement actually probably got kicked off in 2009 at the Velocity Conference, which was actually one of my favorite conferences to go to. And so John Allspaw and Paul Hammond, they were the head of operations and the head of engineering at Flickr and Yahoo. They gave a talk that said, we're doing 10 deploys a day, right? And this is in a, so people were basically fainting in the aisleways, right, saying 10 deploys a day, right? This is in a world where most organizations are doing one deploy every 9 months or maybe one deploy every year. I suspect that if these guys had given a talk at AppSecUSA 3 years ago, here would have been our reaction, right? That's irresponsible, that's wrong, right? That's immoral, right? But essentially what they were saying is that by dev and ops working together, they were getting outcomes that no one else was seeing. In fact, it's so far surpassed what we defined as high performance. I mean, it was literally shocking to me. And what they were saying is that dev and ops are very different disciplines, right? They kind of characterized dev as Spock, being able to sit on the bridge next to Captain Kirk, while ops is relegated to the basement, right? And whenever Captain Kirk says, "Scotty, we need warp speed," Scotty's always saying, "No, we can't do it, Captain," right? And yet, if you can get ops people who think like developers and developers who think like ops people, you can not only create a torrid summer of love, right? But you can get outcomes, right? That genuinely help the business win, right? And by the way, you may be asking, where's information security, right? Kind of in my mind, information security, we're that guy, right? We're the first to be taken out in the away team. And when I wrote the book Visible Ops Security, the words that we came up to sort of characterize kind of our honest, unflinching kind of characterization of our profession, we said, yeah, we're the shrill, hysterical people that everyone avoids because we suck the will to live out of everybody we touch. And we're perceived as the bureaucracy that slows everybody down, right? So, but that's actually not true, right? One last note about DevOps is that DevOps is actually waiting for us with open arms, right? There was another talk at the Velocity Conference, and by the way, this is where organizations like Twitter, Pinterest, Google, they all hang out to share how they're doing what they're doing, which is incredible code achievements and also stability, and security. Theo Schlossnagel said DevOps is actually a terrible name, right? He says it's incomplete, it's prone to misinterpretation, it's isolated. Right? It really should be called star ops. And so what does he mean by star ops? He said, well, maybe it's actually more technically correct, dot star ops, right? Or actually more pedantically, every department ops, right? Because where is QA? Where is information security? Where is network engineering, right? Those are all the disciplines you actually need to get fast feature flow and stability and reliability and security in the operations environment. So DevOps was actually a place that we thought was just a tremendous cultural fit. And we actually have shared values with information security. And I think one of the first people who actually sort of zeroed in on this were 3 people, I think 2 of which are here. Josh Corman, who's currently at Akamai, Jeff Williams, and then David Rice. And what they said is that what we need is a better way, right? Let's see if we can actually create the rugged computing manifesto that sort of aspires to what every developer actually wants, right? And what I think is just one of the most clever sort of sleight of hands I've seen is what they call the rugged attributes. And James Wickett put this slide together. He said the rugged attributes, right? Every developer, every operations person wants things that are available, defensible, securable, with longevity and portability, right? So a developer would call this the non-functional requirements. In other words, those requirements that aren't just features, right? And if we can actually cloak the information security requirements as non-functional requirements, wonderful things happen. And I can say after 3 years of research studying the DevOps community, this is absolutely true, right? There's actually one other insight I'd like to share before I share with you some specific prescriptive patterns that you can actually put into place, in regards to what kind of organization you're working in. One of the things that we found when we studied high performers is that high performers typically tend to accelerate away from the herd. In other words, the best get better. And so 3 years ago, 10 deploys a day was shocking, right, and was generally viewed as a business competitive advantage. These days, I don't think that's considered pedestrian, right? Amazon has gone on record saying that they are not doing 10 deploys a day. They're doing a deploy every 11 seconds, right? They will actually peak doing 1,000 deployments in an hour, right? And that could be as small as a configuration change, or a full rollout, right? And so I think the reason why this is so important to me is that were I to do another startup, I would never do it without using DevOps-like principles. Because if I'm doing one deploy every 9 months, right, and my competitor can do 10 deploys a day, not only can they beat me to market every time, but they can also out-experiment me. In other words, they can do A/B testing all day long, right, and with a cycle time of 1 day, right, whereas it would take me 9 months to actually iterate to the next loop. So fast is not always good, right? The goal of DevOps is not just high deploy rates, right? That's an easily visible characteristic of it, right? But the goal is to win in the marketplace. But fast doesn't necessarily equal better, right? And I think one of the best examples is the Dropbox failure, right? Where someone noticed, that it was actually a customer who noticed that Dropbox authentication services were actually turned off for 4 hours, right? And so here was an example where operations, security, and development were all asleep at the wheel, right? Now you can sort of imagine how this happened. I can imagine, right, that it was a developer who forgot to turn off a debug flag, or they forgot to sort of turn off a configuration setting, right, and that pushed into production. And that should have never, ever happened, right? And so as we are looking at these DevOps-style work streams, our goal is to make sure that we can keep up with those high deploy rates, and there should never be an excuse where an organizational jeopardizing risk like this ever comes into being. So I'm going to share with you the 3 ways, these are the 3 principles that we believe underpin DevOps, and then the prescriptive patterns that you can actually derive from them. Why am I doing this? If I could wave a magic wand, everyone here will be able to, 1, be conversant with DevOps and recognize the practices and the patterns when you see them. 2 is actually be energized about how information security practitioners can contribute in this journey, right? Because my genuine belief is that this is actually one of the most important, significant things and one of the best things to happen to information security in the last 30 years. And I'll be able to leave with some concrete steps to get these incredible outcomes, to replicate these outcomes. And then, maybe most importantly, is be a part of a team, whether they're in dev or ops or QA or network engineering, that actually starts putting these practices into place and get outcomes like they've never had before, and be a part of that team. So the first of the 3 ways is all about systems thinking. It's really as you go from dev to ops, left to right, right? And so why dev and ops? It's because dev and ops are what's between the business and the customer, right? So the business defines requirements, that becomes work in process for dev, then which flows to operation, and that's where actually value is created. If it's not in production, no value has actually been created, right? And so the platitudes and principles that are behind the first way include understanding the flow of work, right, as we go from left to right. And I think one of the big, points for me is that work only goes in one way. Whenever we see work going backwards, that's a problem. 2 is not only do we want work not to go backwards, we want to always seek to increase flow, right? So all the practitioners around lean or theory of constraints, right, they have a whole bunch of techniques, used to that we can use to actually increase flow, primarily, which is decreasing batch sizes. I'll talk about how we do that. The third is how do we never unconsciously pass defects on downstream? In other words, if you look at probably one of the best examples of this is the Toyota Andon cord, which is where if you're in the Toyota assembly line, in fact, I think I have a picture of this. Nope. I have a picture of this later, is that it's actually better to stop the entire production plant than that's actually what they do 100 times a day, right? Because that's far better than actually allowing technical debt accrue downstream. And you can't do any of this without really achieving what Deming would call profound understanding of the system. So the first pattern that comes out of this really came from this statement. As a friend of mine, his name is Ben Rockwood. He's a director of systems engineering at Joyent. So he actually owns the engineering resources for ops and a considerable chunk of the information security responsibilities for Joyent, a cloud services provider. He said annual business planning sessions can be maddening. They think IT is an all-you-can-eat buffet, right? And so one of the things that he reflected back at me was this practice. He said, in order to even talk about the flow of work, you must first define work. And he said there's 4 types of work that you find in When IT Fails, a DevOps novel. He said the first is business projects, right? So that's one that the product managers and the business people will talk about. But what they often don't see is that often atomizes into internal projects. So these are the infrastructure improvement projects. These are the deployments. These are all the things that IT has to do in order to enable or the business project to actually get to the customer. Internal projects often atomize into changes. And then the fourth one is probably the most important one, is the unplanned work, right? These are all the things that IT is doing as a result of failures, service incidents, security breaches, right? And the goal is always to reduce the amount of unplanned work. Most organizations probably spend half the time on unplanned work, often as a result of technical debt, right? So the goal here is to make this visible, right, and show how we can actually aid in the improvement of getting these things done and the eradication of these things. So that's the first thing. Make sure work is visible. Make sure things only flow. And whenever work goes backwards, right, that's unplanned work. So that's practice number one. Practice number two derives from this need. Is like, this is the problem where the developers get together with the product managers in a conference room and they say, we're shipping next week, right? And information security and ops freak out because the application is not even designed to run, right? How can we deploy it next week? We haven't done capacity testing. We haven't finished the pen test. We haven't done the vulnerability scanning, right? So how do we do that? And I would say, to be more clear about the problem here is that the developers have used up all the time in the schedule, leaving no time for the people at the end, right? That includes information security and operations. So there's a second pattern here is designed to mitigate this. The goal here is to create a one-step environment creation process so we can make environments available as early in the development process as possible. So what is the environment? The environment is everything besides the code. Operating system, databases, right? The networking parts, the virtualization layer, right? Everything except for the code. And so ideally, right, you can't get to 10 deploys a day without having a one-step deployment creation process. And the goal here is to actually build the dev, QA, and production environments all at the same time, right? So that means that dev has a dev environment that's consistent and stable, that has some shot at being able to be run in the production environment, in a way that is characterizable and predictable. But there's actually one other change that we need to make, which is, if you're in an Agile process, at the end of each sprint, the goal is to have shippable code, right? But we know that's not sufficient. So we got to change the Agile sprint policy so that at the end of each sprint, we must have working code and the environment it runs in, right? So that means, forever after, right, we'll always be able to deploy without, having operations security, having no time to have an environment. So in terms of specific things that information security can be doing to help enable these steps is, when there is a one-step deploy process, there's typically some tool like Puppet or Chef being used. These are tools that you'll find at Google, at Facebook. It's like it basically handles all the provisioning after you get the operating system laid down. So we want to find wherever these projects are going on, right, and come to them with all of our hardening guidelines, with all of our checklists, and they will actually thank us for it, right? Because what they want is a predictable, stable environment, right? And they're looking for anything that they can get their hands on to actually improve the environment, right? Here's actually where we want to integrate our monitoring in. Here's where we want to put our asserts to find misconfigurations. And another thing that we want to do is just define in advance what changes can actually be pre-approved to go into production versus which change can never go into production without a full review. Like, think about the authentication failure at Dropbox, right? If someone changes that authentication module, even if it takes 4 weeks to test, right, that's what we have to do, right? But let's focus our attention there versus the other changes that don't have such a risk. So the outcomes that we would expect when you put these practices into place include a single repository for code and environment, which is great for security because all the artifacts required to actually create the production environment now live in one place that's auditable. We have determinism in the release process. We have consistent dev, QA, and production environments, all properly built long before the deployment actually begins. And now we're shrinking the cycle times, right? This is where we can go from 6 weeks down to a month, down to weeks, and hopefully down to multiple times a day. And by the way, these things are often tasks, not projects. When I was doing a project with the CTO of AOL, just by changing who was doing the code packaging, we actually reduced deployment times down from 6 hours down to 45 minutes for the AOL.com property, right? Which is a phenomenal boon to information security because now we had one point of accountability of where code audits could be done. And then this is what leads to a faster release cadence. So that's the first way. So the first way is all about left to right as we go from development to operations. The second way is all about, and by the way, where is information security? It's everywhere, right? It's at every point in the flow, right? So the second way is all about right to left. How do we go from operations to development? How do we create feedback loops, right? So we can prevent bad things from happening again and create quality at the source. So the platitudes or the principles that really underpin the second way include understanding and responding to the needs of all customers, internal and external. Right, and the point here is that often we're focused on the external customer, but according to the lean thinking, the customer is any downstream step. Right, so any place where we can make life easier for the next step, right? That's something that we need to focus on. We want to shorten and amplify all feedback loops, stopping the line whenever necessary. I talked a little bit about that. And then we want to create quality at the source. So this is a big platitude, but this is actually, I think one of the best examples of this is designing for manufacturing. In the 1980s, one of the big breakthroughs was when engineering said, hey, our end customer isn't the person driving the Toyota, it's actually the manufacturing people. We must make it impossible for them to actually assemble parts, over tighten, and they started designing things so that they were actually could be manufactured. That was their primary customer. How do we create that in a DevOps work stream? And we do that by creating and embedding knowledge where we need it. So I talked a little bit before about the Toyota Andon cord. This is it here, or specifically here. Right, this is an ad from, I think, Time magazine in the 1980s. And basically, the expectation is that whenever something goes wrong, at a work center, you pull the cord, right? And so this actually ceases production and allows everybody to swarm the problem. And so what is a problem? A problem, it might be a defect in a part. It could be the step is taking too long, right? It took 28 seconds versus 15 seconds. It means any sort of unacceptable deviance, right? And one of the big shocks to me, I actually learned this only a month ago, is that the question was asked, how many times does an Andon cord get pulled in a typical day? And I would have guessed maybe 5 or 10, and the answer is 100, right? It just shows how much importance they put on that, right? And I think it's all because they focus on the flow. So how do we do that between dev and ops, and how do we inject security into that? One of my favorite quotes came from Patrick Lightbody. He was the CEO of a company called BrowserMob. He said, we found that when we woke up developers at 2 a.m., defects got fixed faster than ever, right? I think that's marvelous, right? So the goal here is, we want to sort of create fast feedback loops and give developers the information they need so they know the consequences of the decisions they make on a daily basis. And one of the best ways I found it is actually having developers initially maintain their own service. In other words, never again can they just throw the half-formed pig over the wall and make operations and information security live with the outcomes. And I think one of the best examples of this actually comes from Google. They have something called the HRR, the Handoff Readiness Review. So what it says is that every application at Google has to be managed by developers for 6 months before they become even eligible for what they call SRE coverage, Systems Reliability Engineering. In other words, operations and security are such a scarce resource, right, that you must clear this hurdle before you become eligible to tap the SRE core. Right? And so what is the HRR? The Handoff Readiness Review is, we're going to look at the frequency of page alerts, the maturity of monitoring, architecture review, release processes. And I love this, production hygiene, right? I mean, are you, do you have the work habits and the coding habits that can even make you, palatable for you to actually, run in the production environment? And so what happens when someone fails the HRR? What happens if there's actually, it turns out they are writing fragile code or insecure code? They call it a handback. Right? In other words, you lose the ability to actually run in production and tap the SRE core, right? So I think this is a great pattern of how you can make sure that developers eat their own dog food before things go into production. And by the way, if you're interested in this, this is Tom Limoncelli, who is now at Google, but he wrote a seminal book called The Art of System Administration, which is an O'Reilly book. Okay, so specifically, right? We want to embed development into operations, right? So that includes getting dev into the IT operations escalation process. We want to invite dev to all our post-mortem meetings, any sort of security incident reviews. Right? We want to be. The goal here is to make sure that development can see the consequences of decisions they make, right, and share the pain, right? And we want to have dev and InfoSec cross-train IT operations, right? So I think this is kind of an interesting duality. On the one hand, we want to escalate the development more. But anything that we can actually push down into IT operations, we want to push down to the lowest possible levels we can because both operations and information security, our goal is to create tribal knowledge, not perpetuate individual knowledge. And then we want to make sure that, that we create one single pane of glass where you can see all the relevant metrics, whether it's operations metrics, development metrics, information security, the business outcomes. See them all in one place because this is the information we need to actually restore service quickly. Specific things that information security can do is give feedback to developers, right? Being attacked in production is a gift. In fact, I took this out of Nick Galbraith's slides, a great presentation he gave. He said, capture all instances of, SQL statements being used in user input forms. Graph it and show it to developers, right? Show them on a daily basis. This is a hostile environment which your code is operating in, right? This is what causes behavior changes. Behavior changes is what causes habit changes and culture changes, right? Show all instances of seg faults. I think another sort of very powerful thing we can do is actually create abuse cases, right? So in an Agile process, a very powerful tool is, user stories, so they live above the features, characterizing things from a user perspective. What information security should be doing is create abuser stories, right? So Josh Corman said, hey, a great abuser abuse case is if anonymous DDoS attacks can now sustain peak attacks of 4 million users and 4 to 6 gigabits per second. That should be an abuse case so that we can put that into the backlog so engineers can actually start designing towards that, right? These are how we actually fulfill the non-functional requirements so we can build secure code that's stable, reliable, and can survive attack. This is a Nick Galbraith slide of just showing, hey, here's a great way of showing potential SQL injections and showing this on a daily basis. So here are the outcomes you would expect out of doing this. One is that defects and security issues are getting fixed faster than ever, right? By showing developers, what things are happening to the code and the consequence of decisions they make. We are now actually creating a library of ops and InfoSec user stories that are now part of not just a project we worked on, but then can be reused in every project that now heads towards operations. All groups are communicating and coordinating better, and everyone's getting more work done, right? And ideally here, now this is where we actually start being able to curb the amount of defects going into production. But we can even do better than that, and that gets to the third way. So the first way was going from dev to ops, left to right. The second way is all about right to left, creating feedback loops from ops into dev. The third way is all about creating a culture of continual experimentation and learning. So what do I mean by that? So we want a culture that simultaneously strives for two things. One is saying that we want to experiment and take risks, and we want to learn from failure, right? But two is we need to understand that repetition is a prerequisite to mastery. There's an emerging school of thought that says whether you're in special forces or learning a musical instrument or doing sports training, it is better to practice 15 minutes a day, every day, than it is to practice 3 hours once a week, right? And so why is this important? We need a culture that allows us and expects us to keep pushing into the danger zone, but we have to have the habits that enable us to be able to survive and be able to retreat out of the danger zone when we've gone too far, right? And so doing one rehearsal of a security breach, right, is not enough, right? And I'll show you kind of what it should look like. Adrian Cockcroft, he's a cloud architect at Netflix. He said, we want to break things early and often. We want to do painful things more frequently so that we can make them less painful over time. And when we do this, right, by the way, this guy is an ex-system administrator, right, an ex-security person, actually. He said, we don't get pushback from developers because we know that we're making rollouts smoother for the future, right? And I think one of the best examples of this actually came about, I think it was on April 22nd, April 21st, right? This is the famous AWS failure where every Amazon customer went down, right? And Josh Corman said, painted such a vivid image for me on this. He said when he was presenting at Source Boston at like 10:30, everyone picked up their phones and then left the room, right? Why? Because every organization that was dependent on AWS went down, except for one organization, and that was Netflix, right? And thus came a seminal blog post a couple weeks later that said how they did it. And they said, in order to survive failure, we learned that we had to fail all the time. And that's why we created something called Chaos Monkey, right? So what Chaos Monkey is it runs on every production system in the cloud and randomly kills processes and server instances, right? How many people here would love a culture that says, yes, do all your pen tests unscheduled without telling us, and do it all the time. How many people here would love that? Yeah. So my point here is that in a DevOps-style culture, this is the culture that is waiting for you with open arms. Give me the best you've got, right? And so actually, James Wickett is working on a very exciting project called Gauntlet, and they're working on a larger number of tools called like Security Monkey, Compliance Monkey. We're weaponizing Chaos Monkey, right? So that we can actually do testing in production. And by the way, one of the things I just learned 6 months ago is that, yes, Chaos Monkey runs in production, true, but it runs also in QA, which is probably at a much higher rate. So before you run Chaos Monkey in production, run it first in test. So there are a whole bunch of ways that we can break things in production. We can enforce consistency in the code and the environments and the configurations across all the environments. We want to add as many asserts as we can, not only in production, but in the deployment pipeline. This is actually a great place where we can actually do static code analysis and actually integrate this into the continuous development, continuous deployment processes. And then, what Chaos Monkey really is fault injection, right? We want to inject faults as early as we can, right? Not just in production, but as early as we can in the development lifecycle. And there's just an exciting number of tools, Gauntlet included, Security, Compliance Monkey. These are all sort of designed to run in this continuous delivery process that can support 10 deploys a day or hundreds of deploys a day. But Chaos Monkey without something else is just chaos, right? What we need to do is actually reserve 20% of our cycles to technical debt reduction. So the person who advocates this is a gentleman named Marty Kagan, right? And he is a cultural hero in the product management space. And he says this with authority, and people believe him because he inherited the product management organization at eBay in 2002. And in 2002, for those of you who don't remember, was a time when eBay was experiencing chronic, multi-year, site down issues, right? And he's saying, if you don't reserve 20% of cycles for technical debt reduction, you'll be spending 100% of your cycles on debt reduction, right? Because this becomes that, right? And just imagine why this is so important, right? Is that if you have a site down is because of a cabling error between the SAN and the database server, right? Imagine trying to find that, right? And so when you have 20% of your cycles dedicated for debt reduction, you can actually have the collective will to turn this into that, right? It's great for operational stability. It's great for security, great for code hardening, but it's also great for deployment times, right? You can't do high deployment rates when you have a chaotic operations environment. And I think one of the great hacks I've seen in terms of really enforcing this is when you have a Kanban board or if you have some sort of card system in the Agile process, make all your user features yellow and then make all your debt reduction projects in blue, right? So that means that just at one glance you can see, are about 20% of the cards blue? And more importantly, are they marching across the board, right? Because you want them not only defined in work, but you also want them in production, right? Because if it's not in production, we haven't actually created value. There's actually one other aspect about the third way I want to touch on. In some ways, actually, I think it's actually the most important, especially for the business, is high deployment rates are not just about being able to deploy features faster. Gene is talking too fast. Sorry, guys. This actually came from Scott Cook, the founder of Intuit. He said, by installing what he calls a rampant innovation culture, we were able to do 165 experiments in the peak 3 months of the tax. So this is the TurboTax property. So when I first saw this, I almost fell out of my chair. I said, what sort of idiot would do 165 major changes in the middle of peak tax filing season, right? Most retailers don't even touch production from Halloween till January, right? Because the outage risk is so high, right? So why would they do that? He said, because of those experiments, we were actually able to increase the conversion rate of the website by 50%, right? So in other words, they were actually able to steal customers from the competition that otherwise they would have had to wait a year to be able to recapture, right? So by doing constant A/B testing, by being able to support high deploy rates and simultaneous deployments, you can actually create incredible business advantage by doing this, right? So great for operations, great for security, and also great for the business. So the outcomes of putting the third way into practice. Our technical debt is finally being paid off. Now, for the first time, we're seeing the exploitable attack surface area decrease, right? Because we've bitten off those hard projects and those major refactoring projects, so we can actually make those problems go away. We're continually reducing the amount of unplanned work, which means more cycles for planned work. We have more resilient code environments, and we know this because we're testing and injecting faults both in dev, test, and production all the time. And we're allowing a faster tempo of experimentation and a quicker time to market, right? And by the way, one of the things that I think is just so amazing, right, is that when you have this sort of discipline in place, right, you can find and fix security issues faster than ever, right? No longer do we have to wait 9 months for the next deploy window, right? We can fix things in line. So, the 6 patterns for the three that come from the 3 ways: define the work, make it visible, make those environments available early, right? That comes from the first way. Wake up developers as often as we can, right? But also embed them in the IT operations organization where it makes sense. Third way, break things early and often, and make sure that we're reserving 20% for the paying down of technical debt, right? This is what helps development, operations, and security win. But more importantly, the business will see the value of this. This is how we actually, get fast time to market. This is how we can actually beat the competition, both in time to market and experimentation. But more importantly, I think this is what it feels like, right? This is the feeling of like, hey, we finally got those important projects done. But I love this picture even more. It's like, hey, thank you, information security. You helped the business win. Thank you for keeping the auditors away. Thank you for making sure that these repeat audit issues never come up. Thank you for taking the backlog of security issues and making it all go away, making the environment more secure and more resilient. And then this picture is even better than that, right? This is one of inclusion. This is information security being invited to the deployment party for the first time ever, right? Saying, hey, those security guys are great, right? Let's invite them again on the next release too. And I'm not sure if anyone actually gets to do more with less these days, but we can all do more with less effort, right? And I think that, to me, speaks to something even more urgent than that, right? When I talk about the downward spiral, to me, it's actually disturbing that the downward spiral happens in almost every IT organization, large or small, regardless of what industry, profit or nonprofit. And to me, that's actually the most important problem of all, right? Is that when we are trapped in a system that makes us feel powerless, that preordains failure, that makes us feel trapped in a system that we can't escape, that actually does damage to us as human beings, right? And when you live in a system like that, year after year, right, these are the problems that we take home. Josh Corman and Jack Daniel, they did a study that said the rate of burnout in the information security industry is some of the highest in any job vocation, right, including law enforcement, right? And I think these are the things that our family, they feel that too. So to be able to break that terrible cycle, it just has, I think, has tremendous value just in terms of for us as a profession, but also I think it has incredible business value as well. One of my co-authors, Mike Orzen, we actually did a calculation that said how much business value is there on the table for us to recapture if we could have the amount of waste that's associated with DevOps-style problems and information security problems, and could redeploy that in a way where we could get 5 times the value? The answer is $3 trillion, right? That is a huge number. That is more than the entire economic output of Germany, right, per year. So imagine what that would do to productivity. Imagine what that can do to standard of living. And for me, most importantly, imagine what that does for the world that our kids will inherit. I think this is a phenomenal opportunity, a phenomenal problem that needs to be solved, and a phenomenal opportunity. So I had stated before, if I could wave a magic wand, everyone will be conversant with DevOps patterns and recognize them when you see them. I hope that you're energized about what DevOps can do for us as an information security practitioner and show how it can radically change the outcomes. I hope that you can got some concrete steps that you can actually put into organizations, whether you're a consultant or an employee. And then I really hope that you can be a part of a team that actually puts this into place, because as I mentioned before, right, they are waiting for us with open arms, and we have a lot to offer. And I'm looking forward for you to actually experience that yourself. I'm working on 2 books right now. The one coming out next is When IT Fails, a DevOps novel, which has been one of the most rewarding and fulfilling projects I've worked on in my life. And so we created an organization called IT Revolution Press, and our goal is to positively impact the lives of 1 million IT workers in the next 5 years. And so if you're interested in these slides, if you want a paper called The Top 11 Things You Need to Know About DevOps, If you want the rugged DevOps resources and updates on the book, if you want any of those things, just you can just pick up your phone and text your email address and the number 75894 to the number on your screen, or you can go to this URL and just type in your name and email address. And sorry about the name requirement. That was a fat finger on my part. But anyway, just put in your email address, all right, and you'll get those sent to you instantly. Or you can also sign up at itrevolution.com or email me at genek@realgenekim.me. Thank you so much. I appreciate the time, and I hope you got some value out of this presentation. Thanks.